Okay, so today we're going to be talking about solving some triangles. And so what I want to bring to your mind is kind of where we're headed first, okay? Where we're headed would be like example 3 on the back of your notes, where it says, hey, solve this triangle. And that means I want you to find all the angles and all the sides of this triangle. And I guess the question I'm wondering from you is, do you see how you would do it? And I mean, I can imagine that you would be really good at saying, I can subtract the two angles they gave me to find the missing angle over here. And that's not a big deal. Okay. And so, obviously this right here is going to give us 180 minus 86 and minus 27. And so the measure of angle C is equal to 67 degrees. Okay. But beyond that, it's like, well, how would I find the rest of the sides? I know one side is 19, and then the other two sides are a bit of a mystery. Now, we're going to use trigonometry to help us find the missing parts. And I think the big thing that I would want to state to you guys is the SOHCAHTOA part of sine, cosine, tangent only works with right triangles. Okay, if it has a right angle, then you have an opposite and adjacent, and you have a hypotenuse. But in this triangle, I don't have an opposite and adjacent or a hypotenuse because I don't have a right triangle. And so there are formulas that involve the words, the vocabulary, like the verbiage of sine and cosine, and they're going to be to help find other things. Okay, so even within like science applications, you probably can find some formulas that involve trigonometric formulas that help us find different velocities or angles or things like that are perhaps in non-right triangles. So with that being said, I'm not the expert on physics, but I do know that from geometry, the angle in a triangle is directly related to the size of the side across from it. So if you've got a big angle, ergo, the side across from it will be big. And so in this triangle, if 86 is the biggest angle, the biggest side will be across from it. The smallest angle is 27, so the side across from it would also be the smallest side. Okay, so I'm going to use my pointer, like this side over here would be small side. So the small angle has the small side across from it. The biggest angle would have the biggest side across from it. And we use that in all sorts of applications. Well, the formula that helps us solve using a trigonometry formula, not SOHCAHTOA, but using a trigonometry formula is going to be called the law of sines. Okay, so that's something that we're going to talk about today. And, before we jump into the formula is just down here for the law of sines. So I'll give you that, how you can write proportions, just use the law of sines. Before we get there, I'm going to take you on a little holiday and say, here's how you can kind of see how the formula comes together. You'll not have to do that yourself. You won't have to replicate this, but it's just kind of saying, hey, here's where she comes from. Okay, so if you want to find the area of any triangle, you do area is equal to 1/2 the base times the height. And so 1/2 times base times height in this triangle is going to be 1/2 times base times height. But then let's talk about this using a substitution, okay? This height right here is going to be h. But if we want to change that to be something else, okay, we can go over to angle C and talk about, okay, from C's perspective, can I talk about h a different way? Well, of course we can. And so we'll say the sine of C is equal to h over a. Does that work for you? And then so that means h is equal to a times the sine of C. Like, how are we, why? Okay, well, it's true, if C is here, the sine of C is going to be h over a. Great, solve for h. So we're going to take that h and do substitution, say, okay, if I do 1/2 times b, and instead of h, I do a sine of C, okay, that is equal to the area. Okay, it's additional formula for you to find the area of this very same shape. Okay, and you're like, great, looks lovely. Okay, and then if you say, okay, well, any triangle can be turned on any side, and you can do 1/2 times base times height. And so if you take the very same picture, okay, and you say, okay, let's look over here, and I would redraw it and be like, okay, pretend I call this A down here. Oh, this is still A. Okay. Yeah, it's still A over here. Still A over here. And I call this the height that's perpendicular to A. Because you know you can find the area of a triangle from any perspective. Take a base, find the height perpendicular to it, and do 1/2 times base times height, and you get the area of the same triangle 3 different ways. As long as you have the base and the related height that's perpendicular to it, you're going to be set. So if this is H, and then this is still angle B, this is side C, okay, so the formula for this is going to be area is equal to 1/2 times A times H, and a different way to say H here is going to be the sine from B's perspective is equal to H over C, so H is equal to C sine of B. So we're going to go, our formula for that will become area is equal to 1/2 times A times, instead of H, we're going to do times C sine of B. Like, I don't know that I like this. Okay, well, here's where it gets a little bit fun. Okay, the last one would be if you call C the base. And you're like, okay, this is H. Okay, and then this is still angle B and A and C. And so you're going to say, to find the area from this perspective, it's going to be 1/2 times C times H. And of course, H is going to become, we're going to stand over at A. Okay, so sine of A is going to be H over B. So H is equal to B sine of A. You're like, okay, and then A is equal to 1/2 times C times H, and H is B sine of A. Okay, so where I'm going with this is that all those are areas, so you can set each of those areas equal to each other, okay, because they all should be true. Okay, so the area is equal to this value expression, the area is equal to this expression, and the area is also equal to this expression. So if you set them all equal to each other, okay, so these are all the areas, and you've got area is equal to, from the top equation, 1/2 BA sine of C. The second one is going to be 1/2 AC sine of B. And from the third equation, 1/2 CB sine of A. You're like, great. And you're not going to have to do this. We're saying you can turn a triangle on any side and do 1/2 times base times height. Yes, you can do trigonometry to express the height in terms of the sine of the angle across from it. If you divide each of these parts of the equation by 1/2 ABC, okay, so cross out a half from everybody. And then we're going to divide it by ABC, okay. So I'll have to show this. So it's ABC, 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 and some will cancel out and some will stay the same. Okay, so in this first one, it looks like A and B cancel out. You're left with C. Second one, A and C cancel out. You're left with B. And the last one, you're going to cross out C and B, and you're left with A. So the equation who remains from the area from all three perspectives will be as follows. Okay, you can see what's remaining. And this is the law of sines. The law of sines is the sine of C's perspective over C is proportional or equal to the sine from B's perspective over B. Okay, so side B, which equals the sine of angle A over side A. Now, what do you mean? What I mean is that if you write a ratio of C, okay, so if you write the word sine of C and write it over the length of side C, that proportion, okay, the bigger the angle, the bigger the side across from it, is going to be equal to the proportion of the sine of A from side A, the length of A's side, which is also equal to the sine of angle B over the length of side B. So what they're meaning is the length of each side is proportional or over, okay, you can write this, the sine of the angle across from it is written, can write a ratio. So yes, you can use SOHCAHTOA in right triangles, but you can use the law of sines in any triangle, okay? Any triangle, it can be obtuse, it can be acute. It is awesome, okay? And so we also have 3 formulas of how to find area of a triangle. You know area is 1/2 times base times height, but also the area formula for any triangle. So area is equal to, let's see, 1/2, base times height, but you can do it differently. You can do AC sine times the sine of going to be B. Okay, so just basically the two sides and the sine of the angle between them, okay? The area of any other triangle would be 1/2, and you could do A times B, and then you could do times the sine of C. And then another way you could do it is 1/2 of BC and times the sine of A. So it's just an alternate way to find the area of any triangle is if you know the length of two sides and the angle between them, you can do 1/2 times base times 2 legs, and or not 2 legs, but 2 sides and the sine of the angle between them, and you will get the area of any triangle. So it's kind of cute. I still am prone to use 1/2 base height, just because that's how what I remember, but there is that formula for those of you guys who care. So it says, oh, find the area of this triangle. Well, you want 1/2 times base times height, but you're like, how would I don't know base or height, and nothing's perpendicular. I don't this would be a perfect example of saying, okay, so to find the area of this, you don't know the base or the height. So you do area is equal to 1/2, 2 sides. So you could do A times B times the sine of the angle between them. Okay. It has to be the angle between them. Otherwise it doesn't work. And so, we would do in this case, we would do those 2 sides, and the angle between them would be 1/2 times 19 times 18 times the sine of 47. And if you find that product, you're going to get the area to be approximately 125.06, and that would be units squared. Okay, same with this. If you're like, I don't know that base, it doesn't matter. You do 1/2 times 2 of the sides, 4 times 5 times the sine of the angle between them. And guess what? The area of this is going to be 9.27 units squared. Isn't that weird? And so it's the same as if you knew the base and the height and multiplied them and divided by 2. So the thing is, earlier in this lesson, we talked about, to trying to solve this triangle, you can find the missing angle because two of the angles, you can find the missing angle. But the question is, how would you find the missing sides? You can't do SOHCAHTOA because that only works on a right triangle. So the question is, because of that relationship between the bigger the angle, the bigger the side across from it, the law of sines, where it says the sine of an angle A over the length of that side across from it is equal to the sine of angle B over the length of the side across from it, which is also equal to the sine of angle C over the length of the side across from it. So pick any 2 fractions and set them equal and cross multiply to find the missing parts. And so here we go. So we know we can do, if we want to find, say, this side right here, X, okay, we could say, I'm going to change colors. We could do sine of 27 over X is equal to, okay, and what we know, we have to know a pairing. Okay, you have to know a pairing. We know the pairing that is, and I was like, do we know a pairing? Yes, because watch this. We found this angle here, and we know the side across from it. If we didn't know an angle and the side across from it, we would be in trouble. It wouldn't work for us. So we do, that is equal to, proportionally equal to, because it's in the same triangle, okay, the sine of 67 over the side across from it. Okay, so you have to know an angle and the related side across from it, and you can set it equal to another relationship. Okay, and as long as you just have one variable, you're good. Okay, so we're going to cross multiply and solve. And so we're going to say 19 sine of 27 is equal to X sine of 67. And so to get x by itself, we're going to divide both sides by the sine of 67. You can't divide by sin, but you can divide by sine of 67. Like as long as it has an argument there, you can do it. So x is equal to that quotient. So if you find that quotient in your calculator, you're going to say, well, x is about, where's that going to be? 19 sine of 67 divided by that is going to be 9.37 units. Okay, so that's going to be the measure of side B, or you could say side AC, okay? But you probably shouldn't stick it with X, okay? And round to wherever it says. So that's how I found the measure of side AC, okay, or side baby B, okay? Because the angle B has baby B across from it, okay? The other side we got to find, and again, we can't do the Pythagorean theorem because that only works with right triangles. So you can't do 19 squared plus 9.37, no. And so we're going to do law of sines again. And we know the pairing of the sine of, 67 goes with 19. And we're going to say, so that means, okay, and we can pair that up. We want to find the measure of side A, which is across from capital A angle. And so we could say sine of 86 over side A, okay? So the sine of an angle over the related side across from it is equal to the sine of another angle in the same triangle over the side across from it. And so if we cross multiply to solve, we get A sine of 67 is equal to 19 sine of 86. So A is equal to divide both sides by sine of 67. And if we find that quotient, we will know that A, or side BC, okay, is approximately 20.6 units. So it's kind of a weird proportion where you're like an angle, the sine of an angle over the related side across from it is equal to, in the same triangle, the sine of another angle over the side that goes across from it. So the law of sines is kind of helpful. Okay, so let's try the last two questions. Letter B, okay. So you have to have a pairing, and we do have a pairing. Notice we have the angle that's 24 degrees is paired up with 24. And then we're going to end up finding side D, which is right here, okay, using that pairing, and then we'll end up finding the other side of F. So let's start by finding D, okay? So we know that the sine of 24 degrees over the measure of the side across from, which is actually 24 as well, is equal to the sine of 57 over the side that's across from it, which we'll call D, because it's across from angle capital D, it'll be side D. So cross multiply, you get D sine of 24 is equal to 24 sine of 57. Divide both sides by sine of 24. If you find that quotient in your calculator, you're going to get the measure of side D is going to be approximately, let's see if I'm on the right track, 49.5 units. Okay. And then if we would like to find the measure of side F, we'll call this side F over here. Okay, we have to start with a pairing. We know that sine of 24 pairs up with the length 24 across from it. And then we're going to say, okay, we've got to subtract here to find out what this angle is. And we can do that real quick. 180 minus 57 and 24. That will give this to be 99 degrees. Okay, so sine of 99 over F. Cross multiply F sine 24 is equal to 24 sine 99. Divide both sides by sine of 24. And you get F is equal to that quotient. So side F, or you could call it ED, is equal to approximately 58.3 units. Okay, so it's kind of cute. I think the last thing that I do want to talk about would be, okay, so before we do the last question here, I think what we need to talk about is, there are times where you know one angle and two sides, and, there is something we've got to be careful when we have that, but pretend that we know this angle is, say, 50 degrees, okay? And we know this side is, 15, okay, inches, centimeters, etc. And say that we know that the side over here is 17 centimeters, okay? And we're trying to find this angle right here, okay? We can use the law of sines to help us find it, okay? And so if we go sine of 50 over 15 is equal to the sine of the theta we don't know over the angle who matches with it. So I want us to kind of hold on to that and be like, we haven't talked about that yet. How would we solve it? Well, we would cross multiply to get 17 sine of 50 is equal to 15 sine of theta and divide both sides by 15. So once we find that quotient, we have to do inverse sine to it. Now, when you use your calculator, really make sure that you don't round off and then do inverse sine to that rounded off value. Go up and grab it. And so if we do, I'm going to do the fraction key and do 17 sine of 50 over 15, and I'm going to get a decimal, 0.86. And then I'm going to do second sine. Okay, and I'm going to arrow up and grab that decimal and push enter. I get 60.2 degrees. Okay, there is a bit of an issue. Okay, the law of sines can't find obtuse angles, so that's perhaps why that's not in this notes. But the law of sines only can find acute angles. So sometimes your calculator will lie to you and give you the complement. Actually not the complement, but the supplement to the angle that you're looking to find. So, but that's something that we will have to cover another time. But I do want you guys to be familiar with doing, the law of sines, when we're missing an angle. The other thing we would talk about is you have to have a pairing, right? So if you have angle A and angle B inside C, that does not appear to be a pairing. But if you subtract these two from 180, you get the measure of angle C to be, I've got the answer here, so to make me a little faster, 43 degrees. And so this is pretty straightforward once you get here. You say, okay, well, the sine of 43 goes with 9, and then we could say the sine of A, which is 74, goes with side A. And you could cross multiply and solve, and you get the measure of side A is equal to 12.7 units. And then you would do that again. Okay, so to find the other side B, okay, we'd have to do the sine of angle B, which is 63 over side B. Okay, so this is angle B with side B is equal to the sine of C, which is 43 over side C, which is 9, cross multiply and solve. And that means side B is approximately equal to 11.8 units. So it's cute, kind of cute, to say the law of sines is derived from finding the area 3 different ways, okay? But I'm not going to make you do that. But then also it gives us 3 area formulas. And then also it gives us, you can write a proportion using the sine of an angle over its related side across from it is equal to any other sine of another angle in the same triangle over the related side across from it.